So
Thanks, Helen. Can you see my screen and hear me?
Yep.
Yep, cool. So I'm a PhD student at Monash University under the supervision of Pete Betts and Robin Armit. And we're working on a project similar to Gideon, and we're rethinking the Mossman Orogen geodynamics. So the project is designed to test the hypothesis that the Mossman Orogen records the accretion of several continental ribbons. So like, I suppose in response to Gideon's basin information and trench retreat, we're providing a different hypothesis. It's broken into a few modules. So to achieve this test or test the hypothesis, we need to determine the timing and distribution of major crustal boundaries, investigate the extent and geometry of basement rocks that could compose the continental ribbons. So looking at isotopic signatures of basement of potential source rocks for igneous intrusion, and constrain their geometries and timing. Also the Barnard province, so is it a part of the Thompson Orogen? Have we seen a rift and reattachment of continental crust? Is it an exotic terrain altogether? And how did the tectonics of basement blocks influence the architecture of the Mossman Orogen? So I suppose from an exploration perspective, and how it can help like explorers, resolving major boundaries and crustal blocks will help identify deep-seated fluid pathways and may lead to redefining a terrain and also its potential economic endowment. So I think we're all familiar with the Mossman Orogen now. It's a unique kind of place to study. As Robin said before, the entire history of the Tasmanides is constrained in a narrow continental slither. But as Gideon also touched on, there's evidence to suggest that its evolution is not that simple, and it's more complex than previous tectonic models provide. So ribbon tectonics, that's what we're discussing. Here's a bathymetric map of the Southwest Pacific, and you can see it's riddled with linear ribbons of continental crust, separated by seas and basins. So the Lord Howard Rise, the Norfolk Ridge, part of Zealandia, the New Hebrides Trench, subduction zone, you can see it's contorted as it subducts underneath Vanuatu. So what happens when these continental ribbons interact with subduction margins? So as mentioned before by Gideon, here's this is a clip from the Moresi paper in 2015. So they created numeric models of buoyant colliders interacting with subduction zones. And I'll just try and play it. Yep, there it goes. So you can see the buoyant collider causes congestion and reorganization of the subducting margin as it rolls back and tries to reestablish itself on the outboard side of the buoyant strip. So the deformation is mainly expressed in the upper plate as it is pulled towards a trench during retreat or rollback, and it distorts around the block. So it's creation of an orocline. And if we look at the Mossman Orogen, like as discussed, you can see it's quite an obvious and significant oroclinal structure that creates the western boundary of the Mossman Orogen. So I can skip through most of the regional geology as well, so I save a bit of time there. So a few key domains that we'll look at to explain the tectonic history, and also explain and introduce how the tectonic setting is not quite constrained and it's more complex. So the first kind of question is the Barnard Province. So it's an anomalous slither of older crust on the eastern edge of the Hodgkinson Province. So how did the Barnard Province come to be, and how did the Hodgkinson Province become sandwiched in between Tectonic West Australia, or Tectonic North Australia and the Barnard Province? Also, in the Broken River Province, there's Ordovician Island arcs represented by the Everett's Creek Volcanics and Curry's Well Formation, and like the Grey Creek complex has ophiolitic affinity. So touching on what Robin mentioned before with the Lucky Springs arc, there's Ordovician arcs that we can kind of trace along the western boundary. And further north in the Hodgkinson Province, the Mulgrave Formation features volcanics and volcanic plastics, also with oceanic affinity, island arc affinity. So we're starting to paint a picture of fossilized subduction zones along this margin with accompanying island arcs. Delving into the previous tectonic model, so Henderson and others introduced a accretionary margin model, and they took observations from the Broken River Province, looking at the Everett's Creek and Curry's Well Formation with island arc affinity, and also the Wairuna Formation, and suggested that incipient subduction caused accretion of the magmatic arc and imbrication of the Grey Creek complex onto the Crotonic plate in the early Silurian, and followed by Silurian to Devonian turbiditic formation, deposition of the Wairuna Formation in an accretionary complex, which you can see was represented by that dark purple formation in the map. Alternative models by Voss and others, they presented a back arc basin model based on observations in the north part of the Mossman Orogen. So they interpreted the Mulgrave Formation to represent mafic volcanics and volcanic plastics deposited in a back arc on extending Proterozoic basement or crotonic crust in response to slab rollback. Further extension, ensured immature back arc formation and deposition of the Chiligo Formation. And then as the arc matured, the Hodgkinson Formation, turbiditic deposits were laid down. And then in the late Devonian, potential eastward migration of continental Australia or collision with the volcanic arc system caused back arc basin inversion. So our project looks at a third hybrid model. So kind of combining or explaining observations in these two models and trying to fit in how the Barnard Province fit why it exists outboard of the Hodgkinson Province. So we hypothesized that two continental ribbons were rifted from the North Australian craton during the breakup of Virginia, and continued continental extension led to spreading centers and the development or formation of oceanic crust between the ribbons. So the western ribbon is Hodgkinson Province basement, and the eastern ribbon, Barnard Province basement. During the late Ordovician, back arc basin caused or initiated subduction between the Hodgkinson basement and the Crotonic Australia, and deposition of our Lucky Springs arc rocks on the west side of the Hodgkinson Province. And also subduction initiation between the Hodgkinson Province basement and the Barnard Province basement. And then continued subduction into collision and the creation of continental ribbons. So the sutures now could exist as the Russell-Mulgrave shear zone between the Barnard province and the Hodgkinson province, and the Palmerville fault and the western boundary of the Mossman Orogen, so Teddy Mount fault, Park River fault. So this model, it remains untested. So how are we going to test this hybrid model? So the late Silurian to Devonian sedimentary rocks and the Kennedy Igneous Province cover around 75% of the Mossman Orogen, which suggests that basement architecture was in place and the sedimentary basin was forming by late Silurian to early Devonian. So applying a tectonic setting to the Mossman Orogen requires an understanding of the pre-Devonian basement architecture. So revisiting our accretionary margin model, our back arc basin model, so two contrasting models, and then our hypothesized hybrid model helps explain the Barnard province and the oroclinal bending. Sorry, I don't think I mentioned that. So how are we going to test the model or these models and improve our understanding? And how can we resolve the architecture of the basement? So we're going to use structural geophysics, so seismic, magnetic, and gravity surveys, and geochemistry to understand the composition of underlying source rocks to igneous bodies. So by structural geophysics, I mean predictive interpretation of 3D geometries, looking at the potential dip of structures through magnetic anomalies and their overprinting relationships. I think I've got time, yeah. So I was just gonna run through some preliminary work that I've done. It's just been so far a desktop study, trying to use the high resolution magnetic and also gravity surveys in the area to kind of tease out potential boundaries. So, so obviously magnetics allows us to interpret geology obscured by cover sequences. We'll then kind of hopefully start to resolve crustal domains by grouping the distribution of trends and textures of magnetic responses. So you can see here, this is a part of the, this is on the boundary of the Palmerville fault as it bends around, and it's been obscured by tertiary cover sequences and volcanics. And you can see that there's quite a large magnetic anomaly under here. It's quite linear, runs along the boundary. And you can see some truncation and offset, sinistral offset within the anomaly. So my interpretation of this, or preliminary interpretation, is the linear, it's kind of linear as well. You can kind of start to, yeah, it kind of looks like a possible metamorphic terrain that's been intruded by some igneous bodies. You can also see some obvious volcanics up in the northwest. So there is structures that haven't been discussed in literature that we can see beneath the surface of cover. And similar to what Gideon was touched on, this is the Greenvale province. You can see it's quite a significant and obvious structure. You can pick out the Teddy Mount fault, Vertican River fault. You can see these structures, these kind of indicators, kind of remind us of a dextral sense of movement. So yeah, we need to consider obviously deformation of the Greenvale province and Clark River province when Chatham South province when discussing this oroclinal band. And also you can trace out ophiolitic structures along the boundary, and the Carriers Well Formation and Warrena Formation, which kind of shows continuation and further evidence of a fossilized suture zone.
Are you ready to wrap up, Mick?
Yep, I'll just touch on, this was probably my second last slide, talking about how we're going to kind of map out the basement rocks using isotopic zonation and geochemistry. So we'll be first collating all the data, working out what kind of gaps we can see, and hopefully constructing a few sampling transects that sample the Kennedy Igneous Province. Theorize to tap into the basement rocks and kind of help match up our terrains and help us understand what's happening in the basement blocks, and if they're similar, if they're different, if we can say it's extended crust, if there's exotic terrains or like difference between Thompson Orogen basement and Tectonic Australia extended. And that's all. Hopefully it made sense.